In this pull request, we changed the way the block generator is dealing with teal code. Previously, it had some teal assembly, and it was being compiled for every test transaction that the block generator was creating. With this change, it's going to be precompiled, and that had a pretty significant performance improvement. So before I show the small code change, here is the before and after behavior. So I've instrumented the code so that essentially we're reverting, so the assembled bytes are being reset back to the teal code. So if I build that program, we're going to run the stress scenario, and it is in verbose mode, so there's some extra stuff going on, but for the sake of this demo, it should give you an idea about the performance change. So for some reason, this has been varying quite a bit when I run it. But as you can see, this is much longer than a single block should take for processing. Granted, you typically can't put 25,000 app creates in a single block, which is what this scenario is doing. I'm going to run it a second time after this just to see if we can't get something else. There might be something going on with my computer. Okay, here we go. So in this case, it took 40.5 seconds to generate the test transaction, and it took the ledger 5.5 seconds to evaluate it. So let me just run it one more time and see if I can't get the behavior I see when I don't have a screen recording going on. Typically, I'll see something in the 5 to 10 second range for transaction generation, and then 3 or 4 seconds for the ledger eval. Okay, so this time it was faster. There's still just too many processes going on with my computer right now, but you can see it's taking quite a bit. And this right here is what we're trying to optimize for. This is generating the synthetic blocks. So let me just comment out this, which should bring us back to the behavior in the pull request. Okay, starting that scenario again. The Genesis block is generated very quickly, and let's see how long it takes for the first block. Okay, so here you see it went from 10 seconds to 600 milliseconds, and the ledger eval time is basically the same as it was before. So there you go. So pre-compiling it significantly dropped the time it takes to generate this transaction. So when I'm not recording, it is taking like 200 to 300 milliseconds. So quickly, let's go over the changes. So again, very minimal thanks to the way that this works. So I did add a little bit of instrumentation. So there's the verbose flag is now available to the daemon command. So I needed that for instrumenting the code. Previously, that was only available to the runner subcommand. So here's the main change. When the program starts, we're going to call the logic assemble string function to compile the program, and then we save the program bytes to this. And the reason that works is because here's the instrumentation. And the reason that this works is because these types, approval and clear, are interfaces. So actually, it's assigned to an interface a little bit further below. And when the program gets compiled later on, it Oh, I'm missing it. Oh, here we go. So this is an interface type. And when it's checked before, see a string, nil, or bytes if it's already compiled. So it just supports this intrinsically. So all we have to do is compile it and put it in there. So that's really the only change. Everything else is instrumentation. So it just took some timestamps at a couple tactical places. So here's adding the block to the ledger, and up here, this is a function that calls the evaluator. And of course, at the top, we're stuffing 50,000 transactions in here and timing how long that takes. So that is the entirety of the change.